Hello friends, so today we will discuss chapter number 8, Access Superstep. Access Superstep, it basically talks about the data quality. Data quality refers to the condition of a set of qualitative and quantitative variables. In business, data quality is measured to determine whether the data can be used as a basis for reliable intelligence extraction for supporting organizational decisions. So the main goal is to determine where if individual viewpoints are accurate and complete. The access superstep determine what additional processing to apply to the entries that are non complete. So access superstep basically talks about missing values, incomplete data. If we are able to find out which data is incomplete and we are able to complete it by averaging or by finding the mean median mode, so our data will be more complete and we will be able to get the more accurate decisions. So errors, what are errors? If suppose we are having errors in our data, so the first option that we are having is accept the error. If it falls within the acceptable standard, then we can accept the error, that is West Street, instead of that if it is written as West ST. So what we can decide is whether to keep it or we have to remove it. So in this case we can accept the error because West Street and West ST both are having the same meaning. Now reject the error. Occasionally it is better to simply delete the data entry methodically and not to try to correct it, but we have to remove the data. So that is reject the error. We can add quality flag and use this flag to avoid this erroneous data being used in data science techniques and algorithm that will be affecting the results negatively. So we can have a quality flag. So if our quality is good, then we can use the data, otherwise we can reject the data. Now correct the error. If we go on rejecting, then what will be the problem? The data set may go on decreasing. So instead of that, we have to correct the errors. So this is the option that major part of the access superstep is dedicated to. Spelling mistake in customer name, address and location are the common errors. If there are variation on name, we can set one consolidated and correct across all databases. Using that, we can use it as the primary source. Now create a default value. Most system developer assume that if the business doesn't enter a value, the system should enter a default value. The common values that are entered are unknown or NA. So instead of that, what we can do, system will automatically enter a default value. Now analysis of data. If we are talking about the analysis or the quality of the data, then these are the parameters. Completeness means the data has to be complete at any point of time. Then uniqueness, the data has to be unique. It is to be present on time. Then the validity of the data has to be checked. We have to also check the accuracy of the data, and the data has to be consistent across different tables. So consistency needs to be checked. Now missing values. If our values are missing, so what are the different things we can do? First, we can drop the column where all elements are missing, or we can drop the column where any element is missing, means at least one or two elements are missing. So we can drop that particular column and keep only those rows that contain a maximum number of two missing values. If 3 to 4 missing values are there, then we have to drop those rows. Now it can be decided from one database or one data set to another that whether we have to go with 2 or 3 missing values. Now missing values, fill all missing values with the mean, median, mode, minimum, maximum of the parametric numeric column. If suppose we have collected the data from the student, and the student age lies between 21 to 24, and if a student has not provided the age, so we can put a average of 22 instead of just deleting that particular data. So we can fill it with mean or median or mode or maximum or minimum value depending on the type of data that it contains. So if we are filling it with mean, we have to write test data equal to raw data fill NA, raw data with mean. So wherever the data is NA, we have to fill it with mean. If we are filling it with median, then we have to write NA should be filled with median. If we are filling with mode, then we have to write it as mode, and if we are filling it with minimum or maximum function can be used to fill the data. Now, graph theory is useful for indicating relationship between the entries in the real world. The basic building block are two distinct graph components as follows. Node. The node is any specific single entity. For example, in Henry lives in Jahan. So these are the two nodes, Henry and Jahan. Now what we have to do, we have to create a node like this, and we have to create another node like this, and we have to create the connection if it is a directed graph. Now directions on edges. You can travel from A to C via B, and A to D via B, B to C, and A to B and B to C, and we can travel in this manner. So the directed graph shows that if I want to go to C, I have to move to A, and then only I can go to C, because there is no direct path that exists between A and C. In this way, the directed edges are displayed. Now, directed acyclic graph, we call it as DAG. A directed acyclic graph is a specific graph that has only one path through the graph. So, the first example is the example of DAG, because there is only one path between the nodes. If we have two paths, then we say it is not a directed acyclic graph, because the graph has two paths. So, this is a DAG, the first graph, whereas this is not a DAG, because here from A to we can go to C, via B we can go to C, or we can directly go to C. So there are two paths, that's why this is not a directed acyclic graph. Building a DAG for scheduling job. A DAG is a data structure that enables to generate a relationship between the data entries that can only be performed in a specific order. A DAG is important structure in the core data science environment. It is also used for recording task scheduling and process independencies in processing data. So we can build a DAG for scheduling the jobs. Now, how the scheduling of jobs can be created? This kind of valid routing network can be created. In this network, it shows the place concentrator. We have the country concentrator, then we have the place concentrators, then we have the postal code concentrators, and then the location. So they are connected to one another, and we have the hierarchy. So country concentrator is connected to place is connected to postal code, and postal codes are connected to the location. So the basic validation is as follows. Countries interconnect, forming a mesh network. Places within the countries connect to all in country node, that is a point in the country where all the network connections are concentrated together, called the place concentrators. Postcode can only connect via postcode concentrator. Devices similar to place concentrator but with one per postcode to place concentrator location can only connect to their postcode concentrator. So the locations can only contact to the Postcode can only connect to the place concentrators, and place can only connect to the country. So the data can move upward only in one direction, and if you are the country can connect to the place. So the direction is specified and there are no cycles. So with this, we have completed chapter number 8 in unit number 3. Thank you.